Hello everyone, thanks for joining our talk today. Today we will have a presentation about performance monitoring for Meteor, where we share our experience and insight into how to keep track of your Meteor application performance. A little introduction about ourselves. My name is Phúc Nguyễn. I have been working with Meteor since 2014 when Meteor was still at version 0.6. And you may have known about me via a packet I published earlier called PubSub So recently I joined Pathable to take on the challenge of improving the platform performance. And Oli.
I am on mute, sorry about that. My name is Ole Oskarsson. I'm a developer, techie with almost 20 years of experience building web and mobile applications. The last couple of years I've been focused around Meteor and mobile apps with React Native. Here at Pathable, I do a lot of things, but my current focus is around infrastructure management and monitoring, and is the lead of the performance and security team. And for everyone joining a little bit late, we haven't done the full stuff yet, so that's fine. The presentation is attached in the files if you want to have a high resolution version. If you're having Zoom issues inside the embedded view, you can always open the native client to sometimes solve audio issues. And other than that, back to Phúc.
And please feel free to interact with us whenever you have any question via the chat box on the Pathable on the Meteor Impact website. So before we begin, we would like to give a brief introduction about our company, Pathable. So we are an online platform and mobile app that power virtual, hybrid, and in-person events. And currently we are one of the largest Galaxy customer. Quick intro about our development team. We are having about 20 developers right now, and on about spread out across 4 continents. So we have very open, friendly, and remote culture. And the good news is we are hiring. So please feel free to reach out to us at pathable.com/careers. And we looking forward to see you in the team. So to begin, I would like to give a quick introduction about the general architecture of Pathable. So the Pathable platform comprises of 5 separate Meteor applications running on hundreds of Galaxy containers. We host our database on MongoDB Atlas, and as with many large-scale Meteor applications out there, we already integrated Redis upload into our stack, and we have our Redis cluster hosted on Redis Lab. So during the last 1 year, we have experienced exponential growth, and now we have 50 Galaxy apps across all 3 continents in US, Europe, and Sydney. And during peak time, we might have up to 800 active Galaxy containers, and we expect even more growth in the future. And given that high amount of load, we have been invested a lot in our platform for monitoring the performance of Pathable. Originally, we use the traditional tools that you are probably familiar at, such as the Cloudera API and the Galaxy Dashboard. However, with the exponential growth we experienced during the last 1 year, we have discovered some limitation in these traditional tools. For example, for Galaxy Dashboard, with a very large number of apps and containers, the Galaxy UI may make it difficult for you when you have to click on the lot more button several times to extend a very long list, and it's very difficult to locate a particular app or container. And also when your list of apps and container grow very long, the UI may become unresponsive. And for the Meteor APM, although we still value is very helpful insight into the internal performance metric of Meteor, we sometimes found that it may have put a certain overhead on our server. And also we needed to have a special kind of metric that reflect the performance of DDB response on our Meteor server. But we also want this metric to be uniform and continuous. So this is not provided in the original Meteor APM. So that's why we set out to build a custom monitoring platform of our own, powered by serverless function and Datadog. So my colleague Oli will give you an introduction about this very interesting monitoring platform.
Yeah, so the monitoring platform itself is not built in-house. That is Datadog. Some of the stuff that we're going to do, it might sound like an advertisement for Datadog, but I promise you we're not getting any commission. It's just a very nice platform. We were already using it to monitor our database infrastructure, and I was very familiar with their custom visualization things that you could do inside their dashboards. Their dashboard visualization engine is really, really good. So it was a logical choice to combine those things to get a single view of our entire infrastructure. At the end of the presentation, I will go over an alternative with Elasticsearch Kibana, which could also be useful, but it doesn't provide the same level of integrations and alerting that is actually available inside Datadog. And by having that single monitoring system, we can combine the different metrics and all that we have into a single dashboard or into alerts that only go off if multiple system triggers a certain action. And the specific view you're actually seeing here shows at the top, it's Galaxy metrics about the number of currently connected users, so the WebSockets that are open, number of containers that we're running. We have our own custom metrics in there about the number of events that are currently running, the number of live meetings that are currently running, like this meeting that you're currently in right now, that would show up in one of these statistics. But we also show the database CPU usage, the Redis operations per second. We're monitoring the entire ecosystem of stuff that we're running, and we all have it in a single view, which is why I wanted to dive into showing you what else is possible, because you can go pretty wild with Datadog if you want. So in this case, I'm going to zoom out a little bit. This is not how I normally view it. This is an entire overview of our entire system, everything that we have. You would normally go over this per for the total view or per cluster, as we call it. So we have 7 clusters at the moment, which are separated for regional issues, scaling issues, or other reasons. We have 2 partner platforms, for example, where they run their own events using our software. And this gives you a nice overview of our current system. This is a random time period I chose, October. This is yesterday, actually. So you can see there are actually Pathable is very the load, it's based on US business hours, basically. That's where our biggest traffic comes from. So you can see the connections rising. This is European time that you're seeing here. You can see the connections rising, you see the containers go up, you can see the meetings go up, and we can have a deep dive into a single environment like US1, US2, US3. So US3 is actually where this event is running on. And if we look at what that's doing, I'm expecting, so this is first day of Meteor Impact, I'm expecting this to go a little bit higher today, but at the moment we're basically at the baseline for containers. There's no real load, not a lot of stuff happening. The other environments are a little bit interesting to show. But I want to show you this dashboard just to get you an idea of the kind of stuff we're monitoring and the global view that we have. And I always just love looking at this dashboard, thinking about all the activity that's happening all across the globe. All the important stuff here is auto scaling. So this is not a dashboard I use to make scaling decisions partially. Most of the stuff is auto scaling. Galaxy containers are auto scaling. Mongo has very limited auto scaling. We need to do a little bit of forecasting. but there's triggers and alerts around all this stuff, which wake me up in the middle of the night via PagerDuty if needed, or hopefully my colleague Fook, which is in a completely different time zone, can solve a lot of those issues as well. So I want to give you guys a quick look into that. So how do we actually get those Galaxy metrics into Datadog? Datadog supports a lot of integrations. Galaxy is not one of them. So what we did but Galaxy does have a nice GraphQL API, by the way, which you can use to retrieve the metrics. Under normal circumstances, you'll probably spin up an EC2 instance and a cron job and retrieve those metrics and push them to Datadog in this case. We decided to go a slightly different route, wanted to play around with serverless. Serverless is a concept, so running your stuff without servers, but it's also the name of an NPM package and platform that simplifies the setup and monitoring of JavaScript apps to run on AWS Lambda. They also support other providers. We used the AWS Lambda. So what you're seeing here is actually a screenshot from the serverless dashboard showing our invocations of Galaxy metric retrieval, which looks a little bit like this. So I want to go, this is some pseudocode coming up, but it gives you an idea of how this stuff works. So you have a serverless YAML definition. It's pulling API keys from the serverless key store. So secrets are also safe and managed there. There's nothing in your code. It runs every minute. It invokes a certain function. That function is part of the packets that we deploy via serverless. That function uses the Galaxy GraphQL API to retrieve metrics about containers. In this case, retrieve memory, CPU, retrieve a lot of stuff. This is highly simplified. And you can see we're retrieving the 5-second series that Galaxy actually provides. So Galaxy pings all the containers, everything we're running every 5 seconds. What's the current CPU? What's the current memory? And pushes that to, I think, DynamoDB or whatever. And then they wrap an API around that. We are consuming that. Once we have it consumed, we push it to Datadog. Datadog also has a very nice API via the npm dog API package, which uses the HTTP API. And we're pushing out key values, timestamps, whatever is needed to get to the result that we have. And once you have all that stuff in place, oh, by the way, this Galaxy metrics tool, so the serverless package and the code that retrieves from Galaxy and pushes to Datadog, we'll probably be open sourcing that very soon. If you are interested in using this beforehand, feel free to reach out to me. The Datadog free subscription already has, I think, a generous allowance for custom metrics. This is pushed as a custom metric. So you could probably use this for at least cheap to monitor your Galaxy setup, or other things if you have a different API to consume. This is the end result, a fancy dashboard. We can visualize and aggregate all the metrics. All of these charts that you see here are using the metrics pulled from Galaxy, aggregated either by app, by region, by cluster, or in the case of the CPU outliers chart that you see here, not aggregated at all, and using their Datadog outlier algorithm. So it's just a click and it turns it on to figure out CPU spikes in this case. And what you're looking at here is actually a bug in our code where containers sometimes go into an overloaded state, as we call it. Still unresolved bug. But using this high-level overview, we can see patterns, we can see when it's happening, we can see the containers that it's hitting, the regions, whatever. And after that, we can dive deeper into the logs for that particular container or query analytics or whatever else is needed to actually figure out this issue. So there's some of this, it's monitoring is not just looking at fancy charts, but it's also predicting and finding issues and stuff like that. And I think that's about it for Galaxy Metrics. Over to Fook.
Thanks, Oli. And besides the metrics that we pull directly from the Galaxy GraphQL API, there is a custom metric that we can build and record ourselves. We call it the DDB Health Check. It's also a serverless script that we implemented, And what it does is it will simply initiate a DDB client and send some DDB request to our Galaxy container, and then get back the response, calculate the response time, and then send that result to Datadog. And the nice thing about this compared to the DDB metric you have in the Meteor APM is that this metric is constant because it's recorded every minute, and it is free from all of the production noise, and it's uniform, meaning that we have the same workload for each request. And because it's continuous, we'll be able to produce a diagram illustrating how our DDB performance change over time, which I will show you an example diagram very soon. Next, I would like to give you a brief intro about how we receive the metadata from for the Galaxy container. We still access the Galaxy GraphQL API to get all of those metadata. And in this simplified code, you will notice that we are pulling the status, up, running at, and should stop properties of each container. And these properties will be essential in the next step, which is to filter out abnormal container from our result set. So if we look at the next block of code, here you can see that we are using the metadata container to filter out all of the container that are still too young or are not healthy or are going to be killed soon. We filter out all of those containers. And the reasoning is that because in our experience, we discover that freshly created container as well as unhealthy or container that are going to be killed are not responding to DDBs the same way as a normal healthy container. And because a freshly created container will become a mature container within a couple of minutes, and because an unhealthy container are going to be killed after a couple of minutes from the moment it became unhealthy. So we don't want those abnormal containers to skew our data. So we filter them out and then only retrieve data for the mature, healthy, and living container. And once we get all of those desired container, for each of them, we initiate a simple DDB client, and then we make one method request and one subscription request. We calculate the response time and then send the average to Datadog. And the end result is that we will have a very nice chart that you can see at the top of the slide, where we have an overview of how our DDB performance changes over time. And when you look at those spikes in DDB response time, you may be able to discover when your Meteor server tend to be overloaded and are too slow to respond to DDB requests. And we also use this data to create a monitoring alert on Datadog, where it will inform us immediately whenever our DDB latency goes too high, because that might be a signal of something much more serious, such as too many overloaded container, and in which case we will have to manually scale up more aggressively on Galaxy. So next, my colleague Oli will tell you about an alternative monitoring platform.
No, that's later. The Datadog advertisement continues. I wanted to show you some APM stuff that you can also do with Datadog. So diving deeper into the application itself, into the inner workings of the container and the code. This initially started, just to give you some context, is when we suddenly ran into some unknown Mongo issues. Basically, stuff just died, users were complaining. And I quickly spun up a separate container with Datadog APM wrapped around it to measure the latency from the Galaxy infrastructure to our Mongo provider, to Mongo Atlas. What you're seeing here is a chart. In this particular screenshot, you can see the sudden increase in latency that happened. So normally it's 1, 2, 3 milliseconds. And then suddenly, all of a sudden, it went up to 200, 400, 600 milliseconds per query, which is super unacceptable. And you can also see that the query reads per second dropped dramatically because the containers just couldn't run as many queries as they used to. So the CPU for the database dropped, and we suspect we're in contact with Mongo support actually about this, and we still haven't resolved it, but it hasn't come back. It is related to the number of open connections we had. So when this happened, each container was allowed 100 connections to Mongo, so the pool size configuration. We suspect it's something related to that in combination with auditing system that we had enabled, but we're not quite sure yet. But at least the Datadog APM showed that this issue was on the Mongo side, and we could use this information. And we talked about this information with Mongo support to try and figure out the solution. For now, we've reduced the allowed connections per container, and the problem hasn't returned, but it's something that to monitor. But it's already proven a very valuable tool. But it can do a lot more. It can automatically find the most relevant services in your code. So services would be Mongo or Redis or DNS or TCP Connect or whatever. And what you're looking at here is a full trace for a specific page request. So for the index page request, not DDP or subscribe or anything like that. It's not as good as with that, unfortunately. But you can see here the number of calls that we need to do and actually what kind of calls we're doing. So we're doing a find for pathable permission roles, and there's lots of queries happening there. And you can see the entire get is running on top, and you can have you can mark your own parts underneath. So we do preload data and we do an on-page load at the end, and this gives you a nice overview what's exactly what your application is actually doing, where it's doing it. So we can see that the DNS at the end, TCP Connect, which I believe is an asynchronous push to logs. I don't quite remember what that is, but this gives you a nice example of what is possible if you do the proper APM. And this is an NPM library from them that you need to install, and it tries to, like I said, tries to find all the correct services and libraries that you're using, and you can add your own more traces and wraps. Once you have that in place, it can also provide aggregated metrics on a service level. So what you're looking at here is Mongo. It does some intelligent argument parsing to combine similar calls. And in this case, this is actually another example of an issue that we're having. So you can see there's 270,000 requests to Mongo for a collection called meetings memberships. This was only a couple of page requests. This is not running in production. We use this for performance debugging. We can also run this locally. There is a performance overhead, of course, when you're doing this. There is a cost to this as well. Datadog APM is not cheap if you want to run it on 800 containers. But it is a very valuable tool for performance analysis or during local development. So like I said, I use this quite often. If you're interested in using this for your Meteor application, you can also hit me up. I can have some docs available on how to set this up on your local machine and get this all up and running. Some really cool statistics you can get from this. But to prevent this looking like one big advertisement for Datadog, like I said, we don't get commission, unfortunately. I should probably set up an affiliate link. But I wanted to discuss an alternative performance monitoring tool, which you might be familiar with, which is the Elk Stack. I wanted to put a nice cartoon of an elk. This is more clear. We have Elasticsearch, Logstash, and Kibana, sometimes with beats in between. We are actually only using the EK part, so Elasticsearch and Kibana. We have it running, managed through AWS, so single click. I do a lot of DevOps, but I don't like managing servers and that kind of stuff. I like managed services. And what we needed this for is because of an unfortunate limitation in Datadog is that they don't allow metrics in the future or in the far past. which fits with what they're trying to achieve, performance monitoring. But I had a specific use case where I wanted to forecast what was actually the expected load on our clusters. So in our case, for Pathable, that means expect to forecast the number of events and the number of meetings that are going to happen. So we set up some custom apps. Again, these are actually not serverless. These are part of our metrics app, which has a Meteor cron job inside, sync cron, I think. And pushing whatever data you want, in our case, the custom metrics regarding live meetings in this case, pushing whatever data you want to Elasticsearch is dead easy. There's an Elasticsearch NPM package. It's all JSON. It's everything you're familiar with, and it's super easy to use. As long as, and if you put the right timestamp field in the right, it should be a date format, then it's limitless what you want to do with it. Once you have it in Elasticsearch, in Kibana, so everything I'm showing from now on will be the GUI side of things. You can define an index pattern. You can choose your timestamp field. Once you've done that, the power of Kibana really kicks in, and you can visualize the data in any shape, way, or form. In this case, you're seeing so the red line is now, or at least when I took the screenshot. So it's showing me the past of what happened in the different clusters in our US1, US2, US3 clusters. It's showing the max concurrent memberships for all the live meetings for a certain hour. And it's also showing me a forecast of what to expect today, tomorrow, next week, next month, whatever, however I decide to push the data in. So Elk and Kibana can do a lot of the same stuff we're doing in Datadog with some added bonuses, but missing some other features that we'd like to use. So we use both. And as an added bonus, if you are a Galaxy user, if you have Elasticsearch, you just need to change one environment variable, redeploy your application, and then all your application logs can get streamed to Elasticsearch. And Elasticsearch is really good with handling lots and lots of data. You can visualize it with Kibana, you can search through it. There's a lot of stuff you can do once you have your logs. I'm not going to say not outside of Galaxy, because they'll still also be visible inside of Galaxy, but you'll have a different interface to go over your logs and maybe do some analysis, something that's not possible at the moment with the Galaxy UI. So as a bonus topic, my colleague Fouk is going to go over a very cool system that we recently implemented that can significantly lower your load on your system. So once you monitor everything, that's when you start optimizing.
Thanks, Oli. So we recently implemented an in-house solution called Transstream System. But before I introduce and deep dive into it, I would like to tell you a little bit about the background why we needed it in the first place. So as with many large-scale Meteor applications out there, we integrated Redis offload into our system, and it's a very well-known packet in the Meteor community. It will mitigate the burden of having to tell the Mongo offload, and the namespace system of Redis offload is a very nice way to optimize your pub subsystem. However, during the time we use the packet at Pathable, we discover some drawbacks of Redis offload. The first and the most important significant drawback is that for each mutation to the database, Redis offload make one or sometimes even multiple extra database requests before it sends that trend to Redis. And this may put quite a lot of extra unexpected load on your MongoDB. And the second drawback is about rate conditioning. When the chain reach the Redis server, it may already have become stale, and Redis does provide an option to mitigate this, which is called a race condition protection option. However, if you turn on this option, the number of extra requests permutation will increase dramatically. And in the case of Pathable, it's overloaded our database even with an M300 cluster with 96 virtual CPU, and that's a lot and still overloaded. So in the end, we had to turn it off. So with those reasons, we started thinking about a custom solution called chance stream system. Basically, it's comprised of a Node.js server that will listen to all of the change coming from our MongoDB via a feature called MongoDB chance stream. And once it gets those changes, it process them, queue them, and deduplicate them, and then send them to Redis. So with this model, all changes from the database will flow into Redis via our chance stream server with minimal overhead on the database. And the chance stream system also include a feature called automated failover. So we have a servlet health check mechanism that will automatically turn the failover mode on whenever the chance stream are not working as expected, or maybe when the chance stream server is failing. And when that happens, the whole system, including all Galaxy container, will immediately switch to the old way of using Redis offload. And on the next slide, I'm going to give you some simplified snippet of code to illustrate how do we read change event from the MongoDB. You can see that it's very straightforward. We initiate an npm Mongo client. We create a new chance stream by calling the DB what method from the Mongo client. And then for each change event, we push it to queue and process it, as you can see in the next slide. So for each change event, we queue it, we process and deduplicate it. The duplication here means that, for example, sometimes there's a multiple mutation event happening for a single document almost at the same time. So in that case, we don't want to unnecessarily dispatch multiple similar message to Redis. We want to group them and merge them, and then only dispatch the very latest version of the document to Redis. And we also have some very nice thing called a Redis caching layer for MongoDB query. This is actually not in production yet, but we are working on it, and we hopefully release it in the future. This is like a caching layer for all MongoDB queries. So basically, instead of reaching the database on a Galaxy container, we first see if the document they need is it in our Redis caching layer or not. And the nice thing about this layer is that, unlike traditional caching layer where the cache item need to be invalidated sooner or later, our caching layer is always kept up to date by the chance stream server. So whenever a document change, we update it. We update the snapshot of it in our Redis caching layer. So basically, we are having an evergreen cache layer that we can always access. And currently, this caching layer only support caching based on the ID of document. But in the future, we hope to expand this feature and support a wide range of query with ambiguous selector. That is our goal for the long term for this feature. And next, you can see this is an illustration of the impact of the chance stream system on Pathable production server. Uh, you can see we have records of the system activity on 2 consecutive days, and we only activated the TransStream system on the second day. So you can see the amount of user activity are almost the same, but the amount of Redis operation per second was reduced by 50%, and the amount of MongoDB load was reduced by about 30%. And this is without the Redis caching optimization that I mentioned earlier. When that caching layer is finished, I hope that we can further reduce the load on our MongoDB server and upload it to Redis, because we found that it's much easier to scale our Redis cluster than to scale our MongoDB. And for the future plan, we would like to make the TransStream system become high availability, which means we want the load to be evenly distributed across multiple EC2 instances. And we want the system to be able to continue running even if one or more instances are failing. And we also want to have an automated container level reactivity focus, which means that we want all reactivity chain to be pushed to container only when it is necessary. And we want to achieve that automatically without like having to define a manual namespace system. And finally, of course, we would like to open source it. And we hope we'll be able to do that soon in the near future. So thanks for watching and for your attention. If you have any question, please feel free to ask us via the chat box.
Yeah, so we did a semi deep dive into all this stuff we're doing. Feel free to ask questions in either the Pathable chat box or Zoom. I'm not sure who's using Zoom or who's in the embedded view, but you should be able to get some information to us if you're interested. Contact information will be at the end. So for people watching at home, you can always email us with the same questions that you have, or if you're interested in using any of this stuff. No questions popping up?
You can reach out via email too if you want to reach out later.
Let me show you this. Yeah, in that case, our email addresses are here. You should be able to find us on GitHub or wherever you want to find us as well. Feel free to ask anything about anything related to performance monitoring or what you saw today. And if you do sign up for Datadog, maybe tell them I sent you. Maybe they'll give us a discount. We're paying them a lot of money every month. So, and I think that's about it. There's more stuff coming up this morning in Meteor. Thank you for joining one of these first sessions. The keynote is much later today because basically half of the world is still asleep. There's some chill sessions coming up for the Europeans. There's more interesting presentations, webinars, pre-recorded videos. There's a lot of stuff coming up in the next 2 days, so it's gonna be great. Thank you.
Thank you.
Fuk, you want to sign off?
Yeah. Oh, looks like Jan want to ask us something on the chat box on the Meteor Impact site. One question from Jan: how long do you estimate for open sourcing the TransStream system? This is a very good question. We can. I don't have like an exact timeline in mind, but it should be in the near future, because the next step I want to do is to get rid of all of the Pathable specific code in the code base. And also I want to make the system ready to work with like a generic setup rather than a setup that is very specific to Pathable. And when those are done, I would be happy to publicly release the system.
Yeah, there's for a lot of those tools, there's just some minor things that are needed to publish it, and we should and want to publish it. Pathable is a big supporter of open source. There's another question from Alavi about what our major pain point was with scaling. And I've actually only been with Pathable for a couple of months, but during that time we had exponential growth, as we mentioned, and the biggest pain point we had with scaling is probably reactivity. So in our case, because it is all Meteor and everything is dynamic, there's a lot of queries being fired. And then we reached the end of Mongo scalability, which is also why we spun up new clusters, why we're optimizing what's happening on the back end, why we built the change team server. Almost all of that is to limit the number of queries that are going to Mongo in this case. And Mongo has sharding support. That will be the way to horizontally scale on Mongo. But unfortunately, we can't implement sharding for us easily, at least, because we're doing some complex aggregations. And aggregations, especially lookup, fails on Mongo sharded clusters, which is why we're trying to limit that. So our biggest pain point with scaling has definitely been the database in our case, because Galaxy, the number of containers, it just goes up and away. No issue with that. Redis, we're not even close to the limits. So it's been Mongo mostly. And the reactive nature of Meteor is a blessing, but sometimes also a little bit of a curse because of the amount of queries that are firing all over the place. And we've been limiting reactivity in certain places where needed, actually.
And to address Jan's question about the specific pain point related to time, actually, I think the most critical issue that we face is that sometimes we realize that our system is overloaded too late, and it's not ideal to immediately scale up at that point, because for example, when we scale our MongoDB cluster up, it will take sometime from 10 to 15 minutes, and during the scale up it may have some impact on the performance of the system. So that's why we have been working on an enhanced forecasting capability, so that we can have preemptive scaling to address the spike in the load even before they happen.
Yeah, to add to that a little bit. So Mongo Atlas, it has very nice interface buttons to just scale up and down, and we go all the way from 4 cores up to 96 cores, depending on what we need, because like I showed in the charts, it's very US business hours based. So we don't need the M300 96 cores overnight or during the weekend. It's super expensive. So we are constantly scaling Mongo up and down, and because of the forecasting now, we at least have a little better insight in what to expect for the day or the week or whatever. Just wanted to add that as well. Okay, we're at the 45.
Question.
Oh, are there more questions? Because I wanted to. It's a 45-minute mark. Give everyone some time to get some tea and coffee, because there's another tea session coming up. And or is it the tea session? I'm not sure what's coming up actually. Meteor style PWA and exact code splitting. Okay, I'm gonna go watch that as well. Thank you for your time, everybody. Feel free to reach out, and that about wraps it up.
Thank you. We'll see you later.
Bye-bye.